Okay, so I can see my screen. Hello.
Yes, sir.
Yes, sir.
Okay. Okay. So this epicycloid was discussed in the last class, and just the opposite, I should say, it is my hypocycloid. So let us see the problem first.
Sir, I have a question, sir.
Draw regarding what?
Sir, about the epicycloid, sir, the joining of the curve we will do by the those structure like thing, like
French curves.
French curves.
French curves.
Yes,
Yes.
sir. We will
Yes.
do with that.
Yes. By using French curves. So I think I have told in the last class how you will join, isn't it? Align 3 points, join first 2 points. I
Yes, sir.
think I
Yes,
have
sir.
told that, right?
Yes, sir.
So using the French curves. Now you may have 2, 3 French curves, but you have to check which French curve is aligning properly with the locus points that you are getting. Okay. So according to that, you have to align 3 points and join first 2 points. That is the basically the procedure. Okay.
Sir, will you
Using the
share
French
today's class
curves.
link also?
Today's class, you recording? Hello, recording or what you want? Yes, I will share that. Okay, let me show this one first. Hypocycloid. So if you recapitulate in the last class, what was my epicycloid? So I'll be having a curved path and I'll be having a rolling circle. So the rolling circle was rolling uh, above the curved path, right? Or above the directing circle, I should say specifically, isn't it? So students are still joining, but after 2:20, I will
Sir,
not
will
allow
you
them
share
to join
today's class
anyone.
link also?
Yes, I'll share. I'll share. I'll share. Okay. So that was basically the definition of your epicycloid. So just opposite is the hypocycloid. What is hypocycloid? The rolling circle will roll under the curved path. Okay, under the curved path or the directing circle. This is very easy. These two definition you should not mix. Epicycloid is the rolling circle is rolling over the curved path, and if it rolls under the curved path, the curve pressed by a point on the periphery of the rolling circle for one full revolution, that curve is known as your hypocycloid. Is there any doubt about this definition
No, sir.
in these two
No,
definitions?
sir.
No, sir.
Okay, okay. Thank you. So now we'll learn how to draw the hypocycloid. We have learned how to draw the epicycloid by same procedure. Okay, if you have forgot how to draw the epicycloid, you should not forget because I have discussed in the last class. Still, you can recap that because it is just similar, but in the opposite direction. I will draw. So first task was, if you see the dimensions, the diameter of the rolling circle is given 50 millimeter, and the radius of the directing circle or the curve path is given. So capital R is how much according to this problem? Capital R means
75.
the radius of the directing circle. Yes, 75 millimeter. Okay, and smaller is what? 25 millimeter. This is the diameter. Okay, diameter of the rolling circle. So radius of the rolling circle is smaller, is denoted by smaller. So that is my 25 millimeter as per this problem. So my first step will be same. I have to take a point O on my page, and I have to take capital R. Okay, so I have to take your capital R. Okay, so that is the radius of the directing circle, 75 millimeter, and I have to draw an arc, something like this. Okay, please hang on 1 second. This is the problem. Students are not joining at time. Those who are joining late, if you join late from the next class after 2:15 or 2:17, no one will be allowed. Okay, keep that in your mind. Okay, so you can see the slide, right? You can see.
Yes, sir.
Hello.
Yes, sir.
Okay, okay.
Yes, sir.
Okay, so this is the capital R that you can see. That is a directing circle. Radius of the directing circle, 75 millimeter, has been taken. Then you just join from O to some initial point. You see this line, whatever it is drawn, because as I had told in your epicycloid also, starting point is up to you. Okay, from which point the rolling circle will start to roll. Okay, but it will roll for one full revolution. So the final point we have to fix by calculating the angle theta. Okay, so that is also similar. That equation is also similar like your epicycloid here also, the hypocycloid. So from the O, I'm just drawing a line like this, okay, at any position, which will cut at this point the directing circle. Okay, so now at this is the starting position I'm taking for the rolling circle. Now I have to draw the rolling circle. Now it is very easy to draw, because whenever you are getting this point, from this point you take the radius of this rolling circle, you will get the center point, and you, with the help of the compass, you draw this rolling circle. Now we are considering here my rolling circle is rolling anti-clockwise. Okay, in earlier case we have assumed in epicycloid my circle was rolling clockwise. Here also it may roll in the clockwise direction, but then the car will be in the opposite direction, in this direction. Okay, but here we are just assuming that my circle, the rolling circle, this blue one, this rolling circle will roll anti-clockwise. What will be the difference then? There will be no difference, only the nomenclature will be different. The naming, all the steps are almost similar. I have to divide this circle into 8 equal parts, and also this angle I have to calculate. What is this angle? This is the circle into 8 equal parts, and also this angle I have to calculate. What is this angle? What is this angle? Who can tell me? What is this angle I'm talking about? I told in the last class. Who can tell me? No one. Have you listened the lecture after when
Sir, it is the segment angle, sir.
when I finished and you have told that I have understood, you have understood all. Right? Why we are calculating this theta? Because what I'm doing, this is the blue or the rolling circle. I have to fix one point. This point I'm fixing. I have to trace this point for one full revolution of this circle. So after one full revolution, this rolling circle will be somewhere over here. Are you getting my point?
Yes, sir.
Yes or
Fine.
no? Yes or no? So that position I have to find out. After one full revolution means what? After one full revolution means 360 degree. After 360-degree rotation, because it is a curved path. If it is a straight line, that distance will be you're obviously pi d or 2 pi r. But as here I am having the curved path, I have to, it will create an angle at the center of the directing circle. That angle is your theta. And how to calculate that theta? Same equation that I told in the last class. Theta is equals to your small r by capital R multiplied by 360 degree. That means 360-degree rotation of this small r, how much angle theta it will create at the center of the capital R. That means the directing circle. That is basically the significance of this angle theta. Is this clear? All of you tell me. What is this angle and why you are taking this angle?
Yes, sir.
Yes, sir.
Okay. Okay. So that is basically similar. Those who have understood the last class, they should not be confused, because the same equation I have used. So this here also, this rolling circle is creating an angle at the center of the directing circle. So now what we will do, we will divide So you can see OC is the capital R. OC is the radius of the directing circle, not OC, basically O to this, okay, and C into P. P is this point. Say, consider here it is not written. P is this point. Okay. So this angle will be also divided into 8 equal parts, and this circle will be also divided into 8 equal parts. Okay. So if we divide this angle into 8 equal parts, it will look like this. And how I will do this? Just by bisecting. I have to calculate this angle first, okay, mathematically. Then I have to take this much of angle. This is the final position of this point P. This is the point P. When it rolls and completes one full revolution, the point will come somewhere over here. Okay. So this angle we have divided into 8 equal parts just by your bisecting. Okay, just by bisecting. And then actually they have shown these arcs first, but my suggestion is after dividing these angles, after dividing this angle, you divide this circle first. Okay, divide this circle also, otherwise you cannot draw these arcs. So this is the final position of the circle after one full revolution that you can see, but you may not draw this final position of the circle. Position means this circle you may not draw. Okay, you can draw or you may not draw, that is up to you. So I'm showing this because these divisions, they should show fast, this division of the circles. Okay. Okay, so my point was divide this circle, this 1 2 3 4. You can see the naming here is very important. You can see this circle has been divided into 8 equal parts, isn't it? You can see this. Just concentrate on this circle first, this rolling circle. So this circle has been divided into 8 equal parts or not?
Yes, sir.
1 2
Yes,
3
sir.
4, you can see. Now you see the difference is the naming here. As my circle is rolling anti-clockwise, my naming 1 2 3 4 5 6, this namings will be also in anti-clockwise direction, that you can see. And last point is the P point, that is the 8th point. Okay, that is the last point or P point. So here, the as my circle is rolling anti-clockwise, my naming of 1 2 3 4, these divisions will be also anti-clockwise. Okay. Next, the drawing of these arcs, that is also very similar to the epicycloid part, because O will be the center. Take your compass, O will be the center. O to 4, take as radius, complete this arc, okay, up to this angle theta. O to 3, take it as radius. If we try to draw an arc from 3, it will pass through 5. That is also very obvious. If I start any draw that this arc, if I start to draw from 3, that should pass through 5 if you have divided this circle into 8 equal parts, otherwise it will not pass. Okay, so next is O to C. O to C is my radius, and this central arc line you have to draw. Okay, on which this C1 C2 C3 C4, this locus of these centers will be lying. Okay, because this angular divisions are also cutting these arcs. Okay, so those intersection points are nothing but C. Okay, C1 C2 C3, these points, but it will lie on the central arc line that you can see. Okay, next O to 2. O to 2 will be my radius in my compass, and I will draw an arc which should pass through this point 6. Okay, and I will complete that arc up to the angle theta. Then O to 1, that will pass through 7, and O to 8 or P, that has been already drawn because that is nothing but the directing circle. So up to this, any doubt, tell me, feel free to ask. Yes.
Sir,
Hello.
sir, the length of
Mhm.
radius we cannot take by the scale, so we will take any measurement and draw the radius with
Which radius? Which radius you are talking about? Which radius?
sir, from O to the director circle and there from the rolling circle. That
No, this will be given in the problem. You can see it is given in the problem.
no sir, the the length of the means the so the radius.
Arcs. These arcs.
Yes, sir.
These arcs you are
The
talking about.
radius with
Arcs.
which, so the radius with which we draw the circle, no, sir. So
This
that,
circle.
yes, sir, the rolling circle, no. So that we cannot
Yes,
take.
rolling circle.
So the length of the radius we cannot take with the scale because it is in centimeters. So the
Yes,
dimensions are in centimeters. So we will take any arbitrary
yes.
radius and then we will know.
No, 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 not arbitrary. You see, here it is given 50 millimeter diameter. So what is the radius? 25 millimeter,
Yes, sir.
right? So
Yes.
25 millimeter means what? 2.5 centimeter. You
Acha.
cannot take 2.5 centimeter on this line.
Yes, sir. Yes, sir. Yes. I understood.
So, okay. So that is very basic. You should take, you have to use scale. But some cases, say here it is given 56 millimeter. Try to understand. 56 millimeter. That means the radius will be how much? Radius will be
23.
23.
3 millimeters.
Sorry, not
23.
20, 28, right?
28.
But but say for example it is given 20, this diameter is given 59, okay, 59 millimeter. It may be given in the problem. That means 28.5, 28.5 millimeter is my radius. Then how will you take? Who can tell me?
2.85 or 2.9.
No, you cannot approximate that. Just you have to take, say, by calculating if I am getting radius, say your 20, your 8 millimeter or 28.5 millimeter. I cannot take that by scale. So better, whatever the diameter is be given in the problem, take that separately. Take that straight line separately. Okay, over here. Then bisect that line. Then bisect that line separately. Then you can take the radius in by the help of your compass or not.
Yes, sir. Yes, sir. Yes, sir.
Are you getting my point? You have to take the radius separately. You cannot measure that directly. If you are getting those type of dimensions in the problem, you cannot approximate that. Okay. So take the line separately, take the diameter separately, bisect that. You know how to bisect any straight line. Then take your compass, take the half of that diameter length that you have taken. Then you locate this center of this rolling circle. Is that clear?
Yes, sir.
Okay.
Yes, sir.
So if up to this it is clear, because all the center points I have got, central arc points I have got, then I will take my compass and I will take this CP length in my compass. Okay, that means the radius of the rolling circle, and I will place firstly at C1. I will place firstly at C1, and I will cut which line? Which line I will cut? First line.
Sir, one
That
first
means
line.
First line. First line.
the arc that is coming from 1. I will cut that line. So this one, this much. Okay. So in my compass, what will be the length? CP. Always remember CP, or the radius of the your rolling circle. So name this arc, this intersection point, as P1. Similarly, from C2, I will cut the 2 6 arc. That will be this point P2. From C3, I will cut third. Okay, third arc line, which will be nothing but P3. This one. Then from C4, I will cut fourth arc line. Okay, this is my P4. From C5, I will cut fifth arc line. Okay, that means third and fifth arc line is the same arc line. So I will cut on this side. Okay, because my point is moving towards this side. Okay, so this point is my P5. From C6, rest of the things are almost similar. It will be my P6. I am cutting 2 6 line, and from C7 I am cutting again 1 7 line, which is nothing but P7. And from C8 I will cut 8th line, that means this directing circle. So if I join, I will get this type of curve, which is known as hypocycloid. Is this clear? Hypocycloid,
Yes, sir.
Sir.
clear to all? Okay, but I don't think that I have told in the last class that the tangent and normal to the epicycloid.
Yes, sir.
Have I told?
Yes, sir. You told.
Tangent and normal.
Yes, sir.
This one I told.
Yes, sir.
Yes, sir.
Tangent and normal to the cycloid I told. Tangent and normal to the
So not the
epicycloid I told or not?
epicycloid. You told only cycloid, not
Epicycloid is
epicycloid.
not told.
The to the cycloid you
For
told.
cycloid I told, I think.
It's okay, cycloid
Cycloid.
only.
Yes, yes.
Yes.
Okay, let me show you. Okay, here I'm not having any animation. Just try to understand. I'm having the figure only. So this epicycloid you have got. Okay, okay. This epicycloid you have got. Now at any point on this curve, say this M is the point. At any point, this M, I have to draw tangent and normal to this epicycloid. How to draw? Okay. So take any arbitrary point first on the periphery of the curve. Say this point. Okay. Then take CP or the radius, the CP or the radius of the rolling circle. Okay, in your compass. CP. Place the compass at M, this arbitrary point that you have taken, and cut the central line. And cut which line? Central arc line. You can see on which C1, C2, C3, C4 these points are there. This is that arc, that cutting arc. Okay, so it is cutting at this particular point. You can see the CP length we are cutting on the central arc line. Okay, once we are cutting the central arc line, from that point, take your scale, from that point, join the central point O. Join this initial center point O. This green line you can see. Okay, clear? That from this intersection point, you join just up to O. While you are joining this O, then this straight line will cut this directing circle at this point N. At this point N. Okay, once we are getting this point N, from this point N, just join this arbitrary point that we have taken M initially and extend. That will be the normal to the epicycloid. Is this clear? Is this
Yes,
clear?
sir.
Or I will repeat.
Sir, repeat it.
Sir,
Okay,
repeat
try to
sir
listen
one.
carefully. Okay, try to listen carefully. Listen carefully. I'm repeating. Take arbitrary point, this M, on the periphery of this epicycloid that you have drawn. Take any point. On that point, I have to draw tangent and normal. So your task is to take this radius. Which radius? CP, or the radius of the rolling circle. This one. Take this in your compass. Now, where I will place the compass? I will place the compass at this arbitrary point that I have taken, M. And I have to cut which line? You can see this central arc line, on which the arc line that is coming from C. Okay, on which C1, C2, these points are there. Okay, I will cut that arc line. So I will get an intersection point over here on that arc line. So from that point, you just simply join this O point. Okay, simply join this O point. This green line is that line. Okay, this line. While you are joining, it will cut the directing circle. This is the directing circle or the curved path. It will cut at a particular point N. Okay, name may be different, but it will cut at a point, that is this point here N. Once you are getting this point N, join this point N to this M and extend. Join this point N to this M and extend. That is the normal. And once you are getting the normal, draw 90° to this normal at the same point M. So I will get the tangent, because I know that normal and tangent makes an angle 90°. Okay, now it is clear.
Yes, sir.
Okay, so this is the thing that I should discuss in the last class, but there was lack of time. So today I have discussed the tangent and normal to epicycloid. Using the same method, it is now your task to find out how to draw the tangent and normal to the hypocycloid. That I will not discuss. Okay, using the same method, that much I can give you the hint. So using the same method, you have to draw the tangent and normal to the hypocycloid also. Okay. Okay. So now we will move to the last part of the assignment number 1, that is your involute, the last curve that we have to discuss, involute. Okay, what is the definition of involute? What is the involute? Is again a curve like cycloid, epicycloid, hypocycloid that we have discussed, but here the scenario is a bit different. You can see the definition. What is involute? It is a locus. It is a locus of a free end of a string when it is wound around a circular pole. That means, say you are having a cylinder, some cylindrical part of cylinder you are having, and we are having a string. Okay, so and the string is wound. Okay, string just you can consider wound or any unwound process. Okay, whatever you consider, just we are rolling. Okay, just we are just we are trying to wound that string on that cylinder. So what one so what is involved? It is a locus of a free end. It is a locus of a free end of a string. There will be a free end and another end will be attached to the cylinder. So it is a locus of a free end of a string when it is wound around a circular pole or any, it may be a disc, it may be a cylinder, whatever. Okay, so it is having three cases. Let me show you the problem, then it will be more understood. So as per the definition, what is involved? It is a locus of a free end of a string. That means I am having a string. Okay, that means just in Hindi you can call it is a dhaga. Okay, so or that type of sui or that type of thing. Okay, so and it is, and just we are trying to wound that, okay, on the surface of a cylindrical pole or a cylinder. So by the end of that string, whatever the curve it will be traced, that is basically involute. Okay, so let us go to a particular problem so that okay, now you see, here basically how to draw this I will explain, but say just for example I'm telling there are three cases as I told in the involute question. Here in the cycloid epicycloid or cycloid epicycloid or your hypocycloid, in those problems it will be not mentioned that draw epicycloid or draw hypocycloid, it will be not mentioned, but in the involute it will be it may be mentioned in the in most of the problem, draw involute of a circle. Now what is the three different cases that I was talking about? First case is this one: string length is equal to the circumference of a circle. So this is the string that you can see. Okay, this is the string, this straight line. Say for example, string length is equal to the circumference of a circle. Circumference is how much? If the diameter of the circle is d, obviously the circumference length will be your pi d, isn't it? If this is a disk having diameter d, the circumference will be how much?
Pi d.
Pi d. So and whatever the string I am taking over here for this example, that length is also same, pi d. So this straight line, just consider this is the string. Okay, now if we just try to wound, okay, if we just try to wound this string, okay, around this on the surface of this cylindrical part. So this will, so this is one end of the string. So if I try to trace that end, just it will roll, just it will take the position of this end point like this or not, this p1 p2 p3 p4. How you will get these points, that I will explain later, but this one end of the string will move like this. Okay, and ultimately it will end up over this point where you have been started, isn't it? This physical thing is clear to you or not? Whatever I am trying to explain, that this string length is equal to pi d. If it is equal to pi d, then and if I try to wound that, okay, then the locus of this this end point, because whenever it is coming from this point to this point, my string, this 8 to 1, this small part has been already coming to the surface of the cylinder or not? This part is left. Okay, then it is again we are trying to wound it, then up to 2 it is wound on the surface, again I am trying to wound. Then these are the locus points of the free end of the string. Is this clear to all of you or not? How to draw that I will explain. This how we are getting this endpoints, that is clear to you or not? Please respond.
Yes, sir.
Okay,
Yes, sir.
now what are the three cases that I was talking about? Cases means nothing but the process will be same, the process of the three cases will be same, but this string length may be equal to pi d, may be greater than pi d, or may be less than pi d. I repeat the three cases. The string length, that means let me just take the pen. So this L is the string length. Okay, L may be equals to pi d. Okay, so pi d is the circumference. L may be greater than of this pi d, or L may be less than of this pi d. That means string length, it will be given in the problem. Okay, which that how much long string you have to wound around the that cylinder, and this diameter will be also given. That cylinder diameter will be also given in the problem. So you can calculate this pi d, isn't it? You can calculate this pi d. Then you can check the length of the string is equal to pi d, or greater than pi d, or less than pi d. Have you understood these three cases? Have you understood these
Yes,
three
sir.
cases? So
Yes,
this
sir.
pi d is the main calculation you have to do, as the diameter of the cylinder will be given, and the length of the string that you have to wound around the cylinder or disc, that will be given. So you can easily check which case you are having. But the process is same. The drawing of involute is same. So let us see now how to uh, draw the involute, taking a particular example. So let us start with the first one, when my string length is equal to the circumference of the circle. Should I start? Or if you have,
Yes,
if you are
sir.
having any questions, you can ask. I think I should let me discuss this process, then just you can ask any questions. Okay, so the question is very simple. Draw an involute of a circle. String length is equal to the circumference of the circle. That means pi d is equals to L. That is the case given. So let me go to the problem first. First you draw the circle. Okay, circle or that cylindrical, that means you, that if it is a cylinder, even you have to draw this circle only. Okay, the diameter of the cylinder will be given in the problem. That will that is not given over here in this problem, but if you see your problem in your assignment that you are having, there it is given the diameter. So first you have to take the circle. Okay, taking the dimension, then the same procedure, using the same procedure, you have to divide the circle into how many parts? 8 equal parts.
Eight part, sir.
Okay, 8 equal parts. The naming will be how? The naming will be like this: 1 2 3 4 5 6 7 8, like this. Okay, because my string is like this. Okay, and I'm trying to wound it anti-clockwise, so my naming is getting anti-clockwise. Okay, 1 2 3 4, like this. Can you find any relation why I'm not giving in clockwise?
Yes, sir.
Yes,
So
sir.
that is basically the, that is, if you see, if you have understood the last three curves, the same logic has been used. Okay, by for this naming 1 2 3 4 5 6. So this is the string. I will try to wound it anti-clockwise. So I will be giving the names anti-clockwise like this. Okay, so now that means after drawing this circle from this point 8, draw this perfectly horizontal line. That means that should make 90 degree with this vertical line. How much long? It should be pi d, because the string length is equal to circumference of the circle. So this point is A, and this is the end point of the string, and this is the P. How much this length is? Pi d. So pi d length you have to calculate how much it is, or it is string length is given and string length is equal to your pi d, it is given. So you can take the that length pi d over here from the point 8 up to this P. You can see that is pi d. After taking this pi d, you have to divide this pi d length into how many equal parts? How many equal parts?
The
8 equal
eight
parts,
equal
because
parts.
I
Eight equal
divided
part.
this circle into 8 equal parts. Achha, one question. In the last class, I have discussed the set square method or not?
Yes, sir.
Yes.
Yes, sir.
Yes,
Okay, I
sir.
have discussed it, right?
Yes, sir.
Yes, sir.
Okay. So using that method, no other method, using that method, you have to divide this pi d length into 8 equal parts by set square method. And you have to name it like this: 1 2 3 4 5 6 7 and 8. Okay, this is very simple. Up to this, just I'm drawing a circle, I'm drawing a horizontal line, which is length is my pi d, because string length is your pi d here. Now what I'll do, now see.
Sir,
Yes.
sir, if we use set square method,
Hmm.
do we have to erase the lines
No, no, you have to
after?
keep that, you have to keep that. Okay.
But if we keep the lines, then the whole picture is becoming messy and it's
No, no,
becoming
no, no,
very
no.
difficult for
From
us
the
to
point 8,
draw the.
say you have to divide this line 8 to P, right? This is the pi d. From the point 8, to take a line downwards. Take an inclined line downwards. Okay. Don't take inclined line upwards. Take the inclined line for dividing the length downwards like this, and you follow the process. And that process you have to show. Okay. Set square method you have to show.
Okay, sir.
Now see, after dividing this straight line into 8 equal parts, from each of these points 1, 2, 3, 4, you have to draw a tangent to the circle. Okay. Tangent of how much length? A bit long. There is no particular length. A bit long. Okay. A bit long in length of your this type of tangent you have to draw. That means with this line it is making 90 degree. Okay. That is nothing but tangent to this circle. From each of this, from the point 2, from the point 3, obviously as you are going more 2, 3, 4, 5, 6, the length of this tangents are getting lower, that you can find. Okay. From 1, whatever the length of the tangent will be, at 2 you can draw a bit smaller tangent. Okay. So from each of these points you draw tangent. That means with this line, if I want to draw at point 5, whatever the line I'm having, this line I have to draw 90 degree to that, so that I'm getting the tangent at each of this point up to this 7. Okay. 6, and from 7 also I have to draw some tangents, and from the 8 it is already drawn, the tangent is already drawn. Now you see the last step. Now what I'll do, I will take my compass. I will take which length? From this 1 to P. P is the last point or eighth point. I will take the length 1 to P in my compass, and I will place my compass at this one. Okay. I will place my compass at this one, and I will cut on that particular tangent 1 to P length, so that I will get this point P1. I am repeating this step. Listen carefully. I will take my compass. I will take the distance from this one to this P. Okay. 1 to P. And I will place my compass again to this one point, and I will cut that 1 to P length on the tangent that I have drawn, so that I will get this point P1. Okay. Next, what I will do? Who can tell me? Next step will be, I will take which length?
At 2 to B.
Sir, 2 to P. We can
2
use
to P.
2 to
2
P.
to P.
Take this 2 P. Okay. And where I will cut? I will place at this 2, and I will cut on this tangent. Whatever I have drawn, I will get this P2. So this length you can see, that is my 2 to P. Using the same method, you have to draw from 3 to P. You just take from this 3 to this P, and from this 3 on the tangent you cut that much of length. So that is my 3 to P. Similarly, from 4 to P, 5 to P, 6 to P, 7 to P. What is about 8 to P?
It is the same point as 8.
Sir, it is already
Same point, sir.
It is the
Already
same point. Now here the twist is there. That means this 8 and P will be the same point when my string length and my pi d length, that means when my case L equals to pi d. Okay. When my L is equals to pi d, then only 8 and P point will be same. So as I am discussing this part, so here 8 and P will be the same point. So the last point will be nothing but this 8th point. Okay. So once you have got this all these locus points, just you join these locus points by freehand, because here if you try to use this French curve from this last point, okay, this point will join from the point P. Okay. From point P. So P to P1, P1 to P2, this will not come in your French curve. Okay. Because this is a very large curve. Okay. So try to join smoothly by freehand. So P1, P2, P3, P4, and while the curve will end, the curve will end at this point 8. Okay. Curve will end at this point 8. Is this clear? This is the very simple curve involute. It is much more simpler than epicycloid, hypocycloid. Is this clear, the first case?
Yes, sir.
Yes, sir.
sir.
Okay. Now I'll discuss the another two, that means another two cases, but this process is same. This division of the circle, taking the lines, on which part it is the difference, that I'm going to show you. Concentrate on that. Okay. Now see, we are having a problem, draw involute of a circle, where here what is the case? Can you see? string length is more than the circumference of the circle. That means what is the case? L is greater than or less than pi d?
Greater than.
L means the
Greater
string
than.
length is
Greater than
greater
pi
than
d.
greater than
Greater than pi d.
greater than. Okay, that is the case we are having. So how the involute will look like over here? Let us see. This is the circle. Circle diameter will be given. Draw the circle first. Then divide the circle into 8 equal parts. That step is also same. Okay, name it like this: 1, 2, 3, 4, 5, 6, 7, 8. Now take from this point 8, take the string length. P is the end point of the string. Always remember, P is the end point of the string. So take the string length. Here, say in this problem, it is given 165 millimeter, which is more than pi d. Here the dimensions are not given in the problem, but whenever you see your assignment problem, you can find all the dimensions are given, so you can calculate pi d. And string length is also given, so you can check my string length is greater than or less than pi d. So here you can see 165 millimeter is which length? String length, which is more than pi d. That is clearly written. So first you take the string length, then you take pi d on the same line. Okay, then you take on the same line pi d. So two different lengths, but here in the problem it is given string length is more than pi d. So obviously string length is getting higher. P is the end point of the string, that you can see. Now you have to divide into 8 equal parts. Which length you have to divide? Always remember the pi d length. Always remember the pi d length at this 8th point is the last point, okay, of the pi d length. You can see this line. If you just see this pi d end length, this is the end point of the pi d, and some extra part is there, that is the extra length of the string, because string is greater than pi d, that I know. But which line I will divide into 8 equal parts? Always remember that is your pi d. I will divide the pi d length into 8 equal parts. Is that clear, this point?
Sir.
Yes, sir.
Yes, sir.
Okay, so this 8 to P, you can see in the last case 8 and P was in the same point, isn't it? Because L was equals to pi d. Here L is greater than pi d. So 8 to P is that extra length of the string. Okay, that is the difference in this problem. Now, but the steps are same, how to draw those points. Now, next step will be after dividing the pi d into 8 equal parts, draw these type of tangents, whatever we have drawn earlier from 1, 2, 3, 4, 5, 6, 7, and from 8 it is already drawn. Fine. Now, which length I will take in my compass to draw the locus points?
1 to P.
So first 1 to P.
1.
P.
One
Always
to
remember, don't take 1 to 8. Do not take 1 to 8. 1 to P. Always remember, I have to take 1 to P, or 2 to P, or 3 to P, like this. So I will take 1 to P in my compass. I will place at this one point, okay, on the periphery of the circle, and I will cut 1 to P on the first tangent. So I will get the first locus points. Second one, similarly, 2 to P. From 2, I will cut this P2. Similarly, 3 to P, from the point 3, I will get P3. 4 to P, that means this 4 to P, I will take in my compass. 4 to P, P4 is the locus point. 5 to P, 6 to P, 7 to P, and what will be for 8 to P? What I will do for 8 to P?
We have to place
There is a length, 8 to
The
P.
extra length.
Yes, that is the
So
extra
extra
length.
length,
So
sir.
I have to take that length also, which will not lie at this point 8. That was the last case, but here you can see there is a small length. What is from the 8 to this green point, that my cursor is there. So that length is nothing but 8 to P. So once I have got this all these points, I have to join it. Okay, this is the P8. Okay, now whenever I will join, I will start from P. Again, don't do this mistake. Don't start from this 8, because up to 8 this is my pi d length, but actually my string is larger than pi d. So from this point P starting, just join these points by your smooth free hand, and this P5 point is getting wrong over here, just ignore that point. Okay, P point will be this point, P5 point, this point will be there, P6, P7, and you see it is where it is ending. That is the main difference between these three cases, among these three cases, where it is ending at P8, because I cannot join at this 8 point. I have to join with this P8. Okay. Now after this P8, just to extend that and touch the circumference of the circle. That is your task only. Up to this P8, I don't think any doubt should be there, because just I am going on, just I am joining this, all this P5, P6, P7, then P8, and then what I'll do after P8, I will not leave it. I will just join the curve on the periphery of this circle. That will complete this drawing. So which difference you have found out from the last case? The difference is, you can see the last case means where the string length was equals to pi d, where my curve was ending, it will it is starting from this p, but where my curve was ending in the last
At
case,
8.
Eight, sir.
At
At
the
eight
starting
at
point.
the
point
point
of
8 or not.
the cycle.
But here that is the not. Yes, yes, 8 point, because 8 point and p point was same, that's why it was ending at 8. But if my string length is higher, okay, if my string length is higher than pi d, it will not end up at 8, it will end up somewhere more. Okay, this small length we have to take, and we have to join up to this periphery of the circle. After P8, we have to join up to this periphery of the circle. That will complete this drawing. Is this clear to all of you?
Yes, sir.
Is this clear to all of you? Okay. Now I am
Sir.
moving to the last case. Okay. Last case. Process is similar. There is no difference in the process. Just you have to keep in your mind that this pi d length and this string length. Okay. According to that, you have to. This ending part is very important. Okay. We can check the problem how it is ended. Okay. Because if I know the string length is more than circumference of the circle, then this curve should not end at this point 8. And if you are joining at point 8, I will just cross here and I will give you 0, because you have not understood that problem then. Okay, so that difference you have to check. So the last uh, case is your string length is less than pi d. So I'm just showing you, you tell me is there any doubt or not. There should not be any doubt, because same process we will allow here also. Draw the circle first, that will be given. Divide the circle into 8 equal parts. Okay, give the naming like this: 1 2 3 4 5 6 7 8. Okay, here you see this is the string length from 8 to p, but here what is the case? String length is less, L is less than the pi d. So this is 150 millimeter is the string length, which is less than pi d, and pi d is this much, which is larger. So the values are not given. You can take any particular example to calculate the values. So pi d here is greater than string length basically. So which length I will divide into 8 equal parts? Who can tell me for this
sir,
case?
Pi
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 d.
d
ID.
length.
Pi
Always
d.
remember, don't divide 8 equal parts this 150 millimeter, because that is the string length. Okay, whatever the length you will divide into 8 equal parts, that is your pi d length. So you can see here also 8 equal parts has been divided into this pi, that is for this pi d length. Okay, you can see 8 equal parts. Now what you will do, same process, 1 2 p, that means 1 2, draw these tangents first from all these points. Okay, now see 1 2 p you have to take. Okay, 1 2 p you have to take, and same process, 1 2 p you will get p1, 2 2 p you will get p2, 3 2 p p3, and so on and so on and so on. So the same process, but here you see at p7, 7 to p is this much of length. Okay, 7 to p is this much of length. 8 to p is what? 8 to p is in the opposite direction. That means string length is shorter. I know the string length is shorter, so it will not reach this point 8. If my string length is shorter than the pi d, will it reach this point 8 or not? It will not reach.
No, sir.
No, sir.
No,
So it
sir.
will end up before 8, right? It will end up before 8. So that will be the case.
Yes,
You
sir.
see, okay, you see again another mistake students do. That's why again and again I'm telling. The first was divide this pi d into 8 equal parts. Second mistake that students often do, in this case, when string length is less than the circumference circle, they start the curve from this 8. Okay, they start, sometimes I have seen that they start this curve from 8, but that is wrong. Curve will start from this P, because P is the end point of the string. 8 is not the end point of the string. 8 is the some your, you can say, some virtual length. Okay, up to this 8, but practically I'm having string up to this P, so my curve should start from P. Is this clear? Is this clear to all of you?
Yes,
From where I
sir.
will start?
Yes, sir.
Always from this point P.
Yes, sir.
Okay, so start this curve from this P and join this like this P1, P2, P3, all these points, and it will end up somewhere at this point. Okay, because if just after this P7, you can, how you will get this point, you can just extend this up to this circumference of the circle, or you can do this 8 to P you can take in your compass, and from this point you can cut it, you will get the same point. The circle you just cut, you will get the same point. But this is a very small part, you need not to bother about that. After point P7 you just join this in freehand up to this circle. So have you found the difference in between these three cases of the involute? Right,
Yes,
there
sir.
is a difference with this
Yes,
ending
sir.
part is the main thing, and this starting part also. Okay, rest of the process is same. If you have understood, rest of the process is same. So these are the three cases of the involute. You have to read the problem properly, which case you are having, and according to that you have to draw the involute. Now quickly I will show you the tangent and normal to the involute. It will take 2 minutes. Okay, we are having 5 minutes I think in our hand. So let me show you the tangent and normal. Okay, method of tangent and normal to the involute. So I have taken one example of the involute. Which case it is? Three cases I have discussed. Which
Say
case
L
it is?
say L equals to pi d. L equals to
L
pi d.
equals to pi d. Very good.
Let's go to
Very
pi
good.
d.
L equals to pi d. You can see it is ending up at this point 8. From this point you can understand. Okay. So this is the involute say I am having. So I am taking any arbitrary point Q on the periphery of this involute. At this point what I have to draw? I have to draw tangent and normal. Okay. I have to draw tangent and normal to this involute. How to draw? Okay. First you join from that Q, you join the center point C. Center point C of this circle. Okay, from this Q join the center point C of this circle. Okay, so take this much of length C to Q, take this much of length as the diameter of any circle or half circle. Take this length C to Q as the diameter. So what will be the radius, the midpoint of this? Okay, that means the C to Q, find out the midpoint. That means just bisect it. Just bisect this CQ length. Okay. So then from this center point, from this center point, that means the midpoint of this CQ, complete this half circle. Complete this half circle. Okay, or semicircle. Okay. Once you are drawing this semicircle, you see this semicircle is cutting this roll, this circle or this cylinder, this main circle at a particular point. You can see this or not? This semicircle is cutting this circle at a particular point, just near about one. You can see this or not? Yes or no? Quick.
Yes, sir.
At this point, just mark that point. Just mark that point. From that point, you join the Q and extend. From that intersection point, join the Q and extend. That is basically normal to the involute. And at this point Q, draw 90° to this normal. That will be your tangent. So this is my tangent. This is my normal. So because tangent and normal will make 90°. So this pink line is your normal to this involute, and blue line is the tangent to this involute. This is clear to all of you? Tangent or normal to the involute?
Yes, sir.
Yes, sir. Okay.
Yes, sir.
So actually this completes our assignment number 1. Okay, totally all the 5 problems we have solved, but from the next assignment we will not solve all the problems. We will that means 50% of the problems will be solved by us, and 50% problem you have to solve by own. But as of now, in the assignment number 1 we have solved all the problems. So I will assign tonight in your Google Classroom, your assignment, what you have to do, you have to draw this all the 5 drawings in 5 separate pages. Okay, 5 separate pages of your sketchbook, and you have to make a single PDF file. You have to make a single PDF file where all the 5 problems, solution of the all the 5 problems will be there. Okay, and you have to upload that in the Google Classroom. You have to submit that. Okay, so once I will assign, you will get notification, and some due date will be also given within this puja vacation. We have to submit it, because before puja vacation I don't think will not get any regular class, but your assignment 1 should be you completed within this vacation. So I'll give some due date within which you have to submit. If you are unable to submit within that due date, automatically it will notify me who are submitting late. So if you are submitting within the due date, you will be marked out of 10. Okay, 10 marks are there, as I told, in all the assignments. So, and if you are getting late, then obviously late submission marks will be deducted. Is that clear to all of you?
Yes, sir.
Is that clear?
Yes, sir.
Okay,
Yes, sir.
so I
You say
will
approximately how many days we will get?
at least 7 days you will get. Okay, at least 7 days you will get for drawing. So you have to make a single PDF file, and one thing, don't forget to give the dimensions of all the problems. Don't forget to give the dimensions, as I have discussed how to give the dimension. A drawing without dimension is not having any value. Okay, so automatically marks will be deducted if you forget to give the dimensions. So now we are ending up this class over here, and I will